we're going to discuss are or is the library for plotting. Right? We will be using the library matplotlib, right? And there's another library that is based on matplotlib, known as the seaborn library. Right? So these libraries, we generally use them for plotting purposes in Python. Okay. So let's have a quick introduction to these libraries. Let's say I want to plot a sine function, right? So for that I would need to first create some data, right? And then I can find the sine of that data and then I can plot it, right? So let's create some data, and we can use the function arange in Python, right, to give me an array as a return for this function. But it gives me the first value is the starting value with which I want to start the generation of my data, and then the next one is, let's say, the ending value of the generation of my data, 4 times np dot pi, right? And then I have the step size that I want to have in between these limits. So here I'm generating points between the lower limit 0, 4 times np dot pi, that means 4 pi, and with the increment of 0.1. If I just and then let's say I want to find the sine of these values, so I say np dot sine, and then I have this x, right? If I run this, I can just print the values to see what do I get. What have I gotten here? So you see these are the values going from 0 till 4 times pi with the increments of 0.1. If you want the values with the increments of 0.01, you just change this 0.1 to 0.01, and then if you run the print x, you will see a lot of these values, right? So this is going from 0 to 4 pi, but again in the increments of 0.01. And this y is essentially this sine function applied on this x. Okay. Now I want to plot this y against x, so I can import the matplotlib library. More specifically, I'm going to import matplotlib dot pyplot. So I'm going to import this particular functionality dot pyplot, and I will call it as plt. So this I will be mostly using for plotting. So it says from it says to import matplotlib dot pyplot. This whole thing, just import it and call it the name plt. Then I say plt dot plot, and the first x and y, so it's going to plot y against x, and I need to show the plot, so I say plt dot show. If I run this, you see you got this sinusoidal waveform. If you want to label the axis, so you can say things like plt dot x label excuse me, I say is the x axis, say plt dot y label and say it's the y-axis. And also say plt dot title, the title of the plot, and say this is y equals sine of x. You can see here now you have the title y is equal to sine x, x-axis, and you have the y-axis values. Clear? Questions till this point? All good so far? Yeah? Okay. Now, if you want to plot multiple plots on the same plot, so you can also do that. So let's say I just say here I'm going to just copy it over here, right? And then I say this is I call sine, right? And then I make a cos output, y underscore cos equals dot cosine, say x, right? And then I'll just copy all of this. I say x y, right, underscore sine, and then I want to plot the cosine as well. I can just say plt dot plot x, and then I have y underscore cos, right, so that I can do. And then this is x-axis and this y-axis, and then on the title I can say y equals sine x and y equals cos of x, right? And then I can, to differentiate the two plots, I can say plt dot legend, and with that I can put the name of those different plots. For example, the first one was a sine function. For that reason I wrote sine over here. The second one was a cosine function, so for that reason I wrote cosine over here. And then when I run this, you see y is equal to sine x and y is equal to cos x, right? And this is the x-axis, this is the y-axis. So this one is the cosine function and this one is a sine function. Clear? So far so good? Questions till this point? All good? Okay. So in addition, let's say I want to plot these sine and cosines not on top of each other but as subplots. So that I can also do. So I'll just copy this data, C, Control V, and then I'll create a subplot, say plt dot subplot, and I want to create 2 rows and 1 column. Right. And for the 2 rows and 1 column, right, the first plot I want is plt dot plot x and for example y underscore cos, right, and then I say plt dot title, I say this is a cosine function. If you want to like label the x and y axis here as well, you can also do that, right? And the next one I say plt dot subplot, and here I'm going to put the second plot. So this is the this is telling me that I need 2 rows and 1 column for the plots, and this is the first plot and this is the second plot now. And I can just do this, and here I'll just plot the sine function. this is just the sine function, right? And then I can do plt dot show. If I run this, you see now you got two plots. The top one was the cosine and the bottom one was the sine. And if you want to like increase the spacing between the two, you can do that as well. You want to make the text bold, you can do that, right? If you want to increase the line width, right, make the line thicker, you can do that. So you want to change the color of the line, you can do that as well, right? So there are several different things that you can do. Questions till this point? All good? Yeah? Okay. Now we also have another library, like you have a lot of libraries in Python, right? So one, let me call the so we have sklearn library, for example, right? That is for the scikit-learn library, and scikit-learn library is a Python library that is built on NumPy, but it is for scientific, for machine learning applications, right? And how you import the sklearn library? You import it by saying import sklearn, right? And for instance, I want to import certain modules from this sklearn library. I can say from sklearn import, let's say I want to import the data sets, right? There are some standard data sets of machine learning. Let's suppose I want to import this module data sets, right? I want to import, for instance, a machine learning classifier. His name is SVM, so I can say import SVM, and I can import whatever I want from this sklearn library. Okay, so let's say I import some data sets from sklearn library, and let's say I load a data sets which we call the digits data set. So I can say digits equals data sets dot load underscore digits. If I run this, it's going to load this digits data set. What is this digits data set? You can do digits dot shape to tell what kind of shape does it have. Oops, it doesn't have the shapes attribute. Yeah, so it's in this format. Yeah, it's not a shape. So this data set is of handwritten digits, and you can say digits dot data. So it consists of all these arrays, and each of these arrays are images, right? So this one has 1797 rows of images of size 8 times 8, right? So those 8 times 8 images, they just rotate as one row. So 8 pixels, let's say you have 8 times 8 images, that means you have 8 rows, right? So you can just take the first row, join it to the next row, join it to the next row, and so on and so forth. So this way you can have those 8 times 8 images reshaped as 64-dimensional data. So let's say I can say image underscore 1 equals digits dot data, right? And I want the first row, so I can say the first row and all the columns. And I want to have image 2. So I want to have the second row and I want all the columns, right? So I run this. So image 1 dot shape, if I do that, sorry, I do not need these parentheses. So 64 dimensional. So if I want to reshape it into an image. So how you can do that? There is a function known as reshape in Python. I can call .reshape, and in here I specify the size. So then the output is going to be just an 8 by 8 image. So I say image1.reshape and reshape it in the form of 8 by 8 image. So I say image underscore 1 reshape, for example, is this one. Similarly, I can have image 2 reshaped. You can say image 2. So this is image 1 reshaped as an 8 by 8 image, and this is image 2 reshaped as an 8 by 8 image. Okay. So you can reshape Python arrays into other arrays as well. However, you would need to make sure that, let's say if you have a 64-dimensional array, you do not call this reshape function with 10 by 10, because a 10 by 10 array would need 100 entries, because 10 times 10 is 100. And if you do that, this is going to have is going to complain. It says cannot reshape array of size 64 into shape 10 by 10. Right? It can reshape it into 4 by 16. Why? Because 4 by 16 is 64. But since I know from my knowledge that these are 8 by 8 images, for that reason I'll reshape them into 8 by 8. Okay. Now if I want to show these images in Python, I can also do that. There are several ways to show images in Python, or to display images in Python. One of them is the imshow module in matplotlib. So I can say plt.imshow, and then this. Let's see how does it look like. It looks like this. It's a 0, right? Because these are the high values, right? And these are the low values. I can this one. You see, this is, I don't know what is it, but this again is another handwritten digit. Clear? Now, if I want to, let's say you don't like this kind of an appearance, right? You want the color map to be something else. So you can find the options. plt.imshow, for example, I say color map, not bar. So the CMap is to show the color map. So if the CMap, it has different values. The names, so these are all these names. Wait. These are the names. For example, one of the names will be gray. So let me just change the CMap to gray. CMap equals gray. It's not gray, it's gray, I believe. Yeah. So I want to change it to grayscale, so I just choose the color map gray. Similarly, there are other color maps as well in Python. So moral of the story, each one of these functions or functionalities can have many different options, and if you want to do or you want to plot something in a certain different way, so you will find the option to do that. Questions till this point? All good so far? Yeah, clear? Clear? Okay. So next up, and we will have a quick introduction to this seaborn library. So seaborn library is based on the matplotlib library, right? It just adds more functionalities to matplotlib. So for instance, I just say import seaborn. this is the library name, right? And I say import seaborn as SNS, right? And then let's say I want to load a certain data, which is iris dataset. This is another machine learning datasets that consist of the width of petals or sepals, right, in certain flowers, right? So iris is a kind of flower, right? So I say SNS dot load underscore dataset. I say just load me the iris dataset. If I run this, not data, this one. So run this. So now this data is the iris dataset. So you see these are different attributes: sepal length, sepal width, petal length, petal width, right? And you have the species, right? So species, these are different species of this iris flower, family. Now you can plot this data set in different ways. For instance, I want to plot the sepal length versus sepal width, right? So one plotting way in seaborn is known as line plot, and then I can say x equals sepal underscore length, y equals sepal underscore width. And now here if I say x equals sepal underscore length and y equals sepal underscore width, I have not specified the data. So how can I specify the data? I can just write this as comma and data. So what it will do, it will look at the data, it will take the variables sepal length and sepal width. And how does it know? Because it knows the column IDs of those variables. So we'll just take the data for sepal length and sepal width, right? And then it's going to just plot it. Why is it complaining? Yeah, I need to say data is equal to data, sorry. Data, the input variable data is equal to data. Yeah, so this is the plot. So this is sepal length and this is sepal width. And what are these, these blue lines, right? This is just telling you that how the data is distributed. For example, for sepal length, which is, so this is like the mean, the plot. So this, there are values which are, if the sepal length is like 4.8, there may be values of sepal width around 2.89, right, or 2.85. For the same sepal length, it's possible to have the values around 3.3 or 3.2, right? It's just a plot of sepal length versus sepal width. And since, this is linked to matplotlib, I can also choose titles. For example, I say plt.title, right? So it just will change the title to something else, right? Similarly, there are other functions in seaborn as well, which you can use for plotting. In addition to line plots, they can be bar plots, they can be, pie plots, and so on and so forth. Questions till this point? Is this clear? Yeah. So what we did so far, just to recap, we started with NumPy, right? We finished some of the functionalities of NumPy. Then we discussed what we discussed. Yeah, we discussed pandas, right? Then we discussed matplotlib, right? We discussed how we can use matplotlib to do plots. We can do subplots with matplotlib. We can have many different kinds of plots with matplotlib. Then we quickly discussed that how we can, let's say, show images with matplotlib as well. Then we also discussed the seaborn package, that the seaborn package is essentially an extension of matplotlib, or is built on top of matplotlib. It has a lot more functionalities that are good for plotting. And the cheat sheets for all of these packages, they're already in your notes, so you can have a look at them. Questions until this point? All good? Sounds good. So I will stop here, and we are going to